All right, for lesson 1.10, we are continuing the work that we have started doing. And if you see here, the topic that we're covering in the ready portion is arithmetic and geometric sequences. So we want to find the first 5 terms, then compare each. So in an arithmetic sequence, we know that our first term is 2 and our common difference is 3. So we would know that our first term is 2 and it continues to go up by 3. The geometric sequence is going to start at 2 and our common ratio is 3, so we're going to multiply each next step, the previous one, by 3. So for this first part of A, which one do you think will be more? F of 100. So F of 100, I'm going to keep adding 3 each time, or G of 100, I'm going to keep multiplying 3 each time. I'm going to say that G of 100 is going to be much larger because, and I'll let you write this part out, but I'm thinking it's going to be much larger because I'm multiplying by 3 100 times. That is going to be extremely huge as opposed to adding 3 100 times. For number 2, again, arithmetic sequence, starting at 1, adding 10 each time, or starting at 2, adding 10 each time, so 12, 22, 32, and 42. Geometric starts at 128 and keeps getting cut in half, so 64, 32, 16, and 8. Which value do you think will be more? F of 100 or G of 100? Well, I know that this is going up, I know this is going down, so I should be able to say pretty clearly that F of 100 is going to be much bigger, and I'll let you come up with a reason as to why. Taking a look at number 5, once again, F of 1, and our common difference. This time minus 2, so 62, 60, 58, 56, and G of 1, 64, and continues to get cut in half. Again, which one do we think will be more, F of 100 or G of 100? That one is going to be tricky because this one is getting closer and closer. The geometric is getting closer and closer to 1 or 0. But this one is going to keep subtracting until I get into the negatives. It's going to just keep on going. The geometric sequence is never going to get into negative territory because I'm always cutting a positive number by a positive number. So I'm thinking that at F of 100 and G of 100, G of 100 is actually going to be more because it will still be a positive value. For number 8 and for number 10, we are 8, 9, and 10. We are finding the missing pieces of a geometric sequence. So there are a couple different ways to do this. I'm going to go with the plug and chug, just guess and check. We will have talked about during class, a different method, but I want you to make sure that you're comfortable doing things in a way that's going to work for you. So if I take a look at number 8, I know that it can't be too big because I've got to multiply by itself 4 times to get that number. So if I take 2 times 5, that would get me 10. 5 times 10 gets me 50. That's way too much. If I take 4 times 2 is 8, then 8 times 4 is 32. Again, going to be too much. What if I take 2 times 3? Give me 6. Times 3 would give me 18. Times 3 would in fact get me 54. For number 10, same process. If I take 5 times 4, 20, and I should notice right away that I'm running into some really big numbers here. 100 times 5 gives me 500. So I know 5 isn't going to work. Maybe 4 will. So 4 times 4 is 16, times 4 is 64, times 4 is going to give me 256. Yikes, that's not going to work either. However, it does get me pretty close. So times 3, 12, times 3, 36, times 3, 108, times 3 again gets me 324. So for the go portion, things get a little bit more complex because now we're asking you to take one form and put it into the other form. However, this tells us everything we need to know. As we've been talking about in class, we need to know where we begin and how we move. So for an explicit equation, for a geometric sequence, we know that we're going to be taking f of n equals the first value times the common ratio raised to the power of n minus 1. If you know that formula, the rest of this stuff just falls into place. So here we go. F of n for number 11 equals f of 1 is right here. It's 8 times the common ratio is right here. 2 to the power of n minus 1. That's it. You're done. For number 12, same process. We know our first term. We know the common ratio. So our first term is 4. Our common ratio is 3 to the power of n minus 1. For number 13, same thing. We know our first term, and we know our common ratio. So our first term is 5/3 times 4 to the power of n minus 1. So what I'd like for you to do is to think about which one of those is going to have the greatest value when n is 100. You can plug them into a calculator. You can try it out that way, or you can just stick with what you know. Either way, I hope this helps. Reach out if you have any questions at all.